No, it's not my birthday. Is it your birthday? If it is, happy birthday. If I missed it, it's a belated happy birthday, and if I'm early, well, it's an early happy birthday. Okay, so hey, changing scales here. All right. So let's look at what we got going on here. Remember your scale factor. This is the length in the scale drawing, and we divide it by the corresponding length in the original drawing. All right. So if we're looking at what we've got going on here, and we saw this yesterday. Let's see here. Quotient of corresponding horizontal. So horizontal going left to right. We've got from drawing 1 to drawing 2. So drawing 1 is considered the original because that's what we're starting with. So that's why it'll be in the denominator. So that's why the 2 and 4500ths will be down there, whereas the 3 and 9200ths will be up there. If we do reach for a calculator and we type that in, we do get 1 and 6/10. All right, you don't trust me? Well then, type it in yourself. All right, so vertical distances, and again, the originals when we're starting with, so there's your 1 and 5/10, and then the 2 and 4/10 from the drawing there. Again, you're going to get 1 and 6/10, which is nice because it doesn't matter which one you end up grabbing. So if we think about the scale factor, well, let's convert it into a percent. So it is 160% that we are after, and that would end up being an enlargement. If we do the other one, again, drawing 2 to 1, again, if we go from here to here, now they're saying this is your starting one, so this is your original one, so you will end up with a reduction because you are getting smaller. So we can go through it, but we don't need to do that time. We saw that yesterday. That's just your little your friendly little reminder from before. Now, okay, so these problems are interesting because at first you read through and you're like, there's not enough information. So go ahead, read through it there. Read through it there. All right. Scale drawing from drawing 1 to drawing 2 is 60%. So from here to here, it is 60%. Find the scale factor from drawing 2 to drawing 1. Now, the mistake here a lot of us end up making is we're just like, hey, it's got to go up by 40%, right? Yeah, no. A decline of 60% does not mean going 40% the other way. So what ends up happening here is this is your original amount, so 100%. It ends up becoming 60%. So if you want, we can just change them into whole numbers there. So that's the whole amount. So that means this guy is 6/10 if we end up doing our particular conversion. Now, what's nice about this is we can look at it as a multiple different ways. Remember, every single time the original one goes into the denominator, all right, and then the other one, the scale drawing one, is what ends up going into the numerator that we're looking at there. Now, they want the scale factor from drawing number 2 to drawing number 1. So we're starting this. So this is considered my original. So there's a few ways I can look at this. Is I could put the 60% in the denominator. I could put the 6/10 in the denominator. And if I wanted to get really sneaky, I could put 3/5 in the denominator because I'm changing it to a fraction. Well, if I'm using 60%, that means this guy's 100%. All right. If I use 6/10, that means this guy's 1 whole. And if I use 3/5, it's still going to end up being 1 whole as well. If you do any of these problems, if you simplify all of them, you'll all end up with 1 and 2/3. In other words, 1 and 6/10 repeating. So then when we end up making your conversion, whether it's 2 decimal places to the right, however you want to look at it, that 6 still does repeat, you do get 166 and 2/3%, or that's a bad percent symbol, people, all right, or 166 and 6/10 repeating percent that you can look at. So again, it just kind of depends on which one. Again, we're just giving a value because it's 100%. That's why we're calling it the whole amount. So let's look at example number 3. All right. When we're dealing with this particular problem, we can see to go from 1 to 2. So because this is the number 1 there, I'm calling this as the original. All right. So this is my starting amount that I am dealing with. So which means it's going to be 100%. It's the full amount. So to get to there, it's 112%, so it does get bigger. To get from there, it's 84%, so it does get smaller. So again, if we call this the 100% of the original amount, and this is 1 whole, that's going to make this 1 and 1200ths. Now, wait, where am I getting that from? Well, you're finding 112% of 1. Well, that's your 1 and your 1200ths. So it's just the 1 times the That's where we're getting it from. And then again, if I multiply from here to here, all right, again, I'm taking 84% of my whole amount. Yeah, we're going to get that 84 hundredths. Now they want to know what is it to get from this guy to this guy. So this would be, and again, is the drawing 2. All right, well, let me read through directions. Drawing 2 is also a scale drawing. Drawing 3 is drawing 2 a reduction or enlargement of the drawing of 3, all right, and that would be an enlargement there. It did get bigger. Drawing 2 a reduction, enlargement. Justify your answer using the scale factor. So what we're going to end up seeing here is that we're going from here to here. So when we set it up, because I've got my amounts that we're using, this is considered my original, so that's why it's in the denominator, and then this is my scale drawing. That's why it's going to be up in the numerator. When I do this, I'm going to get 1 and 3/10 repeating. So when I change that to my percent, it's 133 and 3/10 repeating percent. Now, here's the other thing too, is if you're getting confused, like, oh my gosh, which one is it? Which one is it? I don't know what to do. Well, it got bigger, right? So it has to be bigger than 100%. So that is something that we do have to end up watching for. Again, a little bit abstract here, but that's good here. All right. What we want to do here is, in this last one here, we're kind of going to do the same thing as our picture. If this is picture number 1, and then I've got picture number 2, and then picture number 3, they're telling me to go from drawing 1 to drawing 2, that it's going to be the 112%, just like we saw before. And then from drawing 2 to drawing 3, it's going to be 75%. What they want me to prove here is that scale factor from drawing 1 to drawing 3 is going to be 84%. So they want to prove that this does give us 84%. So all I'm going to use is this information right now to prove that I do get the 84% that I'm after. So once again, if this is what I'm starting with, this is 1 whole. And then like we saw before, that's going to make this amount 1 and 12 hundredths, because again, it's 112% of a whole. Now, to go this direction though, this time I'm taking 75% of this number. So yeah, it is a multiplication problem. And guess what happens when you multiply those two together? Go ahead. Come on. Go ahead and say it there. Go ahead. What do you think? What do you think? Yep, you get... Yeah. You get 84 hundredths. Now, why is that so important? Well, remember we were trying to prove this is 1 whole amount, and this is 84 hundredths. It's 84% of this amount to get it, so we did prove it. Now, again, this is the thing about these particular problems is sometimes they want you to prove what is going on, which means, listen, I know what the answer is going to be. You just have to show how we're getting to it, and that's really all that we were doing. So that's all that you had to worry about. So did you have to show a lot to go along with that? Yeah, no, you didn't have to. You didn't there. All right. This one here is more about filling in tables here. We're not going to fill in the entire table, but we're definitely going to look at part of it. What we're doing here is scale factor. We're going from drawing 1 to drawing number 2. So drawing 1 to drawing 2. So when we do that, that would make this one the original. That's why it's in the denominator. And when we do this, we end up with our 1 and 2/10, which is your 120%. So again, it is an enlargement. Now what they're saying is, okay, how can we show this when it ends up happening? Well, if we took the original amount and we took 120% of it, when you do the multiplication, guess what you're going to get? 1 and 2/10. So it does end up proving what we've got. Drawing 1 to drawing 3. All right, so again, 10 is the original. That's why it's in the denominator, and 8. So there's your 8/10, which is 80%. And it's the whole idea is that if you take 80% of the original amount, all right, you get 8/10, and excuse me, you don't get 8/10, you get 8. All right, and why is that significant? Well, because well, look, it's 8 right there. All right, I think I said 1 and 2/10 up here. I apologize to that there. All right, that should be a 12 because it matches up with the 12 right there. And let's do one more. Drawing 2 to drawing 1. Drawing 2 to drawing 1. So this is now my original. So that's why the 12 is going to be in the denominator. The 10 is going to be in the numerator. Again, don't get scared of repeating decimals. So really what we've got going on, if we change it to a percent, it's 83 1/3%. Again, because if I go 2 places to the right, I still got the 3/10 that's repeating. So, all right, if we take our percent of 83 1/3% and we go ahead and we multiply it by our 12, it does result in a crisp, clean 10. Now, again, if you're not too sure about this, what we can end up doing is changing it into improper fraction if you would like. The other thing that we can do is there's nothing wrong with using the conversion button on your calculator to change that into a fraction. But wait a second, why would I need to do that? Isn't it 10/12? Yeah, it's 5/6. So again, don't go into panic mode like I can't do this, I can't do this. We've actually got the work right here that's what it is, the fraction. So if you do 12, all right, and you multiply it, oops, let's sorry, I have a little problem here. All right, let's see. Let's start over. If you end up taking your 12, I'm going to do the work up here, and then you multiply it by your 10/12. All right, well, hey, 12 over 1, a little cross division. Look at those. Oh, my goodness, we get 10 just like we had said. So, again, don't go into panic mode with it there. Repeating decimals, get them into fractions, and that's where you want to be at with it. So we're going to stop you there. I don't think we need to fill in the rest of the table unless you feel that we really need to. If you do, then by all means continue. But if not, you're done.